Alright, so we are going to open up to our very last set of notes in this unit. It is 4.4, number 2 notes. So notes number 1, we learned all about multiplication, and that's what we practiced last week. And then this week we're going to talk about multi-step stuff. So it's the notes that look like this. All right, and our goal for today is to learn matrix properties. And if we know the matrix properties, then we're going to be able to solve multi-step. So to solve multi-step matrix problems. So I have one review problem for you because this is the trickiest thing we've done so far, and it's the multiplying of matrices. The first thing that we have to do is figure out if we can or cannot multiply them. What do we need to do in order to figure out, can we multiply these two matrices? Write out the dimensions. So the dimensions of this one here is a what? A 3 by 2. Go down 3 over 2. So 3 by 2. This one here is what? A 2 by 3. Can we multiply these? Yes. Why? The 2's in the middle tell me that this can multiply. What is my product going to be if my middle numbers are 2 by 2? Then that means you take out that middle man and your answer has to be a 3 by 3. So when I go to do my workbox, I'm going to make it a 3 by 3. I'm going to make it as large as I can based on the room that's given. There wasn't a ton of room on this one. And what's going to help me is if I circle what in this one versus what in this one. What do I circle first? Rows or columns? Rows in the first, columns in the second. So in the first one, I'm going to circle rows. So I have 3 rows. Just like here, I have 3 rows. So in this top row, what number do I use? 1 and 2. So I'm going to have a 1 and a 2, a 1 and a 2, a 1 and a 2. In the middle row, what numbers did I use? -4, 3. So I'm going to put -4 and 3 in my whole middle row. And I have 2 numbers circled, so I know that I'm going to have 2 pairs of numbers here. And in this last row, what numbers are used? 0, 1. So I'm going to have a 0 and a 1, 0 and a 1, 0 and a 1. I circled rows here. What do I circle here? Columns. Notice when you circle the columns, you're also circling 2 numbers. The reason? Because we had those magic matching 2's in the middle there. That's how I know I'm going to have 2 pairs of numbers. So in this very first column, and notice we have 3 columns circled. We have 3 columns. What numbers are circled in the first column? 5 and -2. So we know that 5, -2 is going to be in every single one of these boxes. So 5, -2, 5, -2, 5, -2. And what I'm doing is I'm going to add, once I multiply those and multiply those, I'm going to add these numbers together. So let me put a plus sign in between them. Okay. What are the numbers that are used in that middle column? 7 and 3 are used in the middle column. So each of these will have a 7 and a 3, a 7 and a 3, a 7 and a 3. And in that last column, what numbers are used in the last column? A 0 and a 1. So a 0 and a 1, a 0 and a 1, a 0 and a 1. And now that we have all the pairs written out, now we can go to actually just simplifying each of those boxes. So I'm going to write out boxes again. And I'm just going to do the multiplication. So 1 times 5 is 5, plus 2 times negative 2 is negative 4. So again, you can use your calculator here if you don't know your multiplication tables, or you could know your multiplication tables and just multiply in your head. Negative 4 times 5 is negative 20, plus 3 times negative 2 is negative 6. 0 times 5 is 0, plus 1 times negative 2 is negative 2. 1 times 7 is 7, plus 2 times 3 is 6. Negative 4 times 7 is negative 28, plus 3 times 3 is 9. 0 times anything is 0, plus 1 times 3 is 3. Did I do something wrong? Oh, you looked at me like I was, like one of those numbers were wrong, and I was like, oh shoot. Maybe I need to learn my multiplication tables. Alright, 0 times 1 is 0, plus... Do you have your phone, Mrs. Fox, or your calculator? 2 times 1 is 2. Negative 4 times 0 is 0, plus 3 times 1 is 3. 0 times 0 is 0, plus 1 times 1 is 1. So when we multiply matrices, it is a lot of work. Okay? Next, we can write our actual answer. So our answer is going to be a 3 by 3 matrix. We're going to draw the brackets in now because we actually put our answer in the form of a matrix. 5 plus negative 4. So you can do that on your calculator or you can do it in your head, whichever works best for you. Answer is 1. 7 plus 6 is 13. 0 plus 2 is 2. So we have 1, 13, 2 up at the top. Next row, negative 20 plus negative 6 is negative 26. Negative 28 plus 9 is going to be negative 19. 0 plus 3 is 3. That middle row, we have negative 26, negative 19, 3. And in that last row, 0 plus negative 2 is negative 2. 0 plus 3 is 3. 0 plus 1 is 1. Okay. Give me a 1 to 5. How do we feel about multiplying matrices? So some people wrapped that on their quiz last week. Other people tried to just multiply things in the same space. Or they told me that this you couldn't even multiply because they said, not same dimensions. The thing with multiplying is they do not have to be the same dimensions. What's important is that the columns in the first have to match the number of rows. Okay. So, I went through and did some properties for you and showed an example of each. Now, the reason why we have to know properties is because if I am asking you to do multiple steps, we need to know what is allowed and what's not allowed. Okay? So if we're talking about real numbers, numbers we deal with every day, can you do 3 plus 2 and 2 plus 3 and get the same thing? Yes, you can change the orders of adding. If you do 2 times 3 or 3 times 2, do you get the same thing? Yeah, but the problem is with matrices, you have different rules. So you're not always allowed to just change the order of things. So I went through and gave you some examples. Now when it comes to adding matrices, it doesn't matter the order because you know that you're just adding them. Okay? Subtracting is a little different. It would matter the order unless you distribute that negative sign as a scalar. But here I showed you the commutative property, meaning can we do GH and it equal the same thing as HG? So can you multiply in this order and in this order, and are you going to get the same thing? So I went through and I did the work. Here's G, here's H. And when I did the work, these were the answers that I ended up getting. Do you get the same thing if you multiply in a different order? Are these the same matrix? No, they're not even the same size. And sometimes, which we did learn this when we did our notes the other day, sometimes you'll be able to multiply it one way, but you won't be able to multiply it the other way. So you cannot change the order of matrix multiplication. Okay, so what we can conclude is that order matters when multiplying two matrices. So that's our big conclusion there. So you cannot just change the order. Okay. We could also write that GH does not equal HG. Okay, those two answers were not the same. This next one says, can we test the distributive property? Okay, so if we put a matrix out front and two matrices that add together, is that the same thing as if we were to distribute the J to both the things on the inside? So here's what we would have. We would either have the J on the outside or the J distributed to both things on the inside. And so here, what we did was we took the K and the L that were 2 by 2 matrices, we added them together, and this was our answer. And we left that J matrix out front. And then we multiplied these together, and this was our answer. Okay. On this one here, we distributed the J to both of them. So we have J times K. We did the work. We got this answer. We did J times L. We did the work. We got this answer. Then we took these two matrices and we added them together, and this is what we got. Did we get the same thing both times? Yes. So you can distribute. So our conclusion is that you can distribute as long as you keep the same order. So notice J was on the outside on the left, so we had to keep it on the left when we distributed. So that's our big idea in this section. So if we have a J on the outside, and we have K plus L on the inside, this equals the same thing as putting J next to K and putting J next to L, as long as you left it on the left, since it was originally on the left. So we'll call it left distribution. It was originally on the left, the J was originally on the left, it has to stay on the left of both the K and the L when you distribute. So on the back, we have a couple more properties just to talk about, and then what we'll do is we have a couple of examples that we'll do together. Or is it okay if I go and flip this? All right, so properties of matrix multiplication. For any matrices A, B, and C. Okay, so when we write these rules out, A, B, and C are going to be matrices when the matrix product is defined. So we're going to assume that we can multiply them. Scalars will be write as K, and the following properties are true. Okay, so we talked about the commutative when you're switching the order. That one was not true. Okay, these 4 properties all work. So the associative property is grouping things together. So if I have 3 matrices, A, B, and C, and I multiply them together, so matrix A times matrix B times matrix C. Remember, if I don't put anything in between the letters, it means multiplication. So if I have 3 matrices multiplied together, you could do this a couple different ways. You could group A with B, multiply these 2, and then take that answer and multiply by C. Okay? Or you could leave A outside and multiply B times C first, and then take A times that answer. One thing that you cannot do, though, is change the order, because we already talked about that commutative property that order matters. So it has to be in the order of A, B, C, A, B, C, A, B, C. You can group them together differently, but order matters. You cannot change the order. So we'll write that over here. So don't change order, but you can group any 2. That's the big idea. If you have to multiply 3 things together, and that works just like if we had numbers. If I had the number 2 times 3 times 4, I would group 2 of them together and say 2 times 3 is 6 times 4. 6 times 4 is 24. It's the same idea with matrices, although we know multiplying matrices takes quite a bit longer than just multiplying 2 numbers together. Okay. The associative property of scalar multiplication says that if we have a number out front, remember the scalar is the number out front. The number out front that you just distribute to everything, to all the elements in the matrix. Okay, so that scalar is a number out front. If we have K times A times B, you can do this a couple different ways. You can take A times B, multiply them together first, then take that scalar and multiply it. Or you could do this scalar times A and take that answer and then multiply by B. Any of these options would work for you. So if you see a number times a matrix, you could go either of these routes. Is that okay? All right. The left distributive property, we already talked about that. We said that if you have a matrix A and then 2 matrices B and C that are added together, okay, so all 3 are matrices, a matrix times 2 matrices that are being added together. You could do it like this, or you could distribute the A and do A times B plus A times C. I wouldn't recommend doing that way, because this way you'd have to do a multiplication and a multiplication, versus this one, it's easier to add and then multiply one time, right? Because multiplication is what takes the long time when you have to build the box and figure out the rows, figure out the columns, fill everything in, do all that math. So I would recommend to go this route, would probably be the easier route to go if you see something like that. Add the 2 together, then multiply A times that answer. The same idea kind of goes if we had, if the A was just on the other side. So that's just right distributive property. So if you have 2 matrices added together and a matrix on the right side of it, you can distribute it also. You just have to make sure that the A stays on the right side. This might be more helpful if you saw that you had a setup more like this, where you're multiplying each matrix by the same matrix, A, and then if you could like undistribute it, it might be more useful to come out this side it wouldn't take as long. Okay. So we'll actually do a couple problems here. The first one is multiplying all three together. Okay. Now there's no parentheses here, but we can form them. So do you want to try to multiply the first two together first, or the the last two? First two? Sure, we can do that. So you're just going to think about this as there's parentheses around these two. And we're going to fill in this answer. And then we'll have that times this 1, -7, -4, 3. Whatever that answer is, we'll go right here. Then we'll have that matrix times the matrix, and we'll be able to do this. But first we have to figure out, can we even multiply these two together? So, what's the dimensions of this first matrix? A 2 by 3. What are the dimensions of the next matrix? 3 by 2. Can we multiply them? What's our answer going to be? A 2 by 2. And actually, I might as well write these as brackets, not parentheses, because I won't need parentheses there anymore. Okay, so once I get this answer and it's a 2 by 2 times a, what's this, the dimensions of this next matrix? It's a 2 by 2. Can I multiply a 2 by 2 times a 2 by 2? What's my final answer going to be? Okay, so that's kind of my work to even figure out, okay, can I multiply these? Is it going to work? So far, are we okay? So now I know that I'm not wasting my time. I actually can go about doing this. Okay, so what I'm going to do first is this set of parentheses. My answer there is a 2 by 2, so I'm going to take this and I'm going to do a giant workbox. It's going to be a 2 by 2. Okay. And remember, you're going to circle rows in the first. So what numbers are going to be in this top row here? -2, 6, and 8. And remember, they all have to show up in every single one. So we have a -2, a 6, and an 8. -2, a 6, and an 8. I know I'm going to have 3 sets of numbers, or 3 pairs of numbers, because I circled 3 numbers. What numbers do I use across the bottom row? -1, -8, 7. Good. Then, I know I'm going to be looking at columns in this one here. Okay. So, what numbers do I use in this first column? Yes, 2, -7, -1. 2, -7, -1. In the second column, I'm going to be using the second column of numbers. So -4, -3, and 1. -4, -3, and 1. And what I'm going to be doing is I'm going to be adding these multiplication pairs together. So far, so good? Now from there, if you really want to, we could just enter this all in your calculator and put the answer right here, and the top right one, put the answer right here. So if you want to show more work, that's fine. Or if you want to say, okay, on this top box, what I'm doing is -2 times 2 plus 6 times -7 plus 8 times -1. That answer is going to get me -54 in that top box. Is that okay? So you can use your calculator and type in the 3 pairs of multiplying and add them together all at one time if you wish to do that. So go ahead and do that now, and let's find these other 3 numbers. Alright, so my answers I got here, when I did this in my calculator, I got -54. When I did this in my calculator, I got -2. This one in my calculator, I got 47. And this one in my calculator, I got 35. Give me a 1 to 5. How did those go? They looked pretty good as I was coming around, for those that did that. Okay, so now what we have is we multiplied these two together and got this answer. And so we have that answer times that third matrix still. Do you guys know how to multiply a 2 by 2 times a 2 by 2? Yeah, so this last part shouldn't be anything new then. This last part is a 2 by 2 times a 2 by 2 is going to get me a 2 by 2. So when I multiply this together, I'm going to need a 2 by 2 workbox. And you're going to look at the rows in the first. So in the top row, what two numbers do you use? -54 and -2. -54 and -2 across the top row. Okay. What numbers do we use in that bottom row? 47 and 35. And 47 and 35. Okay. What numbers do we look at, or what do we circle in this second matrix here? The 1 and -4, so you circle this column, and then this column. So in the first column, I'm going to be using numbers 1 and -4. Oh, I did that wrong. Sorry. Column, not rows. 1 -4, 1 -4, 1 -4. In the second column, I'm going to be using -7 and 3. -7 and 3. I know that with these pairs of numbers, I'm going to be adding them. So I'm going to go through and put my plus sign in between the pairs. And I can type this right into my calculator again so I can put my final answer here. -54 times 1 plus -2 times -4. -46 in that first box. This one here, -54 times -7 plus 2 times, -2 times 3, 372. This one here, 47 times 1 plus 35 times -4, -93. And in the last box, 47 times -7 plus 35 times 3, -224. Okay. All right, so looking at this next example then, we have two things that are multiplying plus another two things that are multiplying. So just as PEMDAS says, you have to do the multiplication before you add. So what we're going to do is we're going to multiply these two together and get an answer. Multiply these two together and get an answer and see if we can then add them. Okay. So first off, let's see if we can multiply these. What are the dimensions of that very first matrix? 3 by 1. Times, what are the dimensions here? 1 by 2. Can we multiply them? Okay, what is our answer going to end up as? A 3 by 2. So we're going to have a 3 by 2 plus. Okay, in this one we're going to figure this out. What are these dimensions here?
3 by 2.
A 3 by 2. Times 2 by 2. Can you do it? What's your answer going to be? A 3 by 2. Can you add a 3 by 2 and a 3 by 2?
4.
Yes. Yes, because when we're adding, they have to have the same dimensions because you add each element with the same element in the same location. Okay? So we are going to be able to do this problem, but that's kind of how you're going to look at it to figure out, can you do this problem? So, there is a shortcut here. Anyone see it? When you multiply these two together?
Identity matrix.
This is your identity matrix. So do we have to actually show our work to multiply these together?
No.
No. What's our answer going to be when we multiply those two together? It's going to be what it started as, this 3 by 2 right here. So we're going to have this negative 8, negative 7, 4, negative 2, 2, negative 1. So when we multiply these two together, this is our answer, because it's multiplied by the identity matrix. So that's that one, plus, let's multiply these two together. We know that we're going to have a 3 by 2 workbox. We're going to be circling rows in the first. And there's only one number in each of those rows. So when we write our numbers here, we're only going to have one pair to have. Okay? So in the first row, what number do we use? 0, 0. What number do we use in that middle row? 1 and 1. Number in the last row? Zeros. Okay. Then we look at the columns in the next one. Again, we only circled one number. We only circled one number because one number and one number make a pair. One pair. All right, first column we use 5. So we use 5 all the way in the first column. Second column we use what number? Negative 8. So, what does this equal then? We multiply these two matrices together to get this. We multiply these two together to get this. We're still adding matrices together. The second one is already done, so I don't need to do anything there. I still have the negative 8, negative 7, 4, negative 2, 2, negative 1. This first one, though, however, we can do the multiplying. So 0 times 5 is 0. 0 times that is 0. Then we're going to have a 5 here, negative 8 here. These are multiplied by 0, so those both turn into 0. Are we okay so far?
Yeah.
Now, you could have shown your work when you multiplied by the identity matrix. You could have done your boxes there, but this would be the answer that you end up getting. So we just took a shortcut. Okay, can you add these two matrices together? How do you add two matrices together? Look at them and do the matrices in the same element. So like 0 and negative 8 are in the same element, same spot. The first row, first column, first row, first column, add those up. What is 0 and negative 8 added together? Negative 8. What is 0 and negative 7 added together? Negative 7. What is 5 plus 4? What is negative 8 plus negative 2? What is 0 plus 2? 2. 0 plus negative 1? There we go. That would be our final answer right there. So that was actually quite a bit less work than number 1. Number 1 was the hardest one when you have to multiply all 3 of them. Okay. Number 3 is one of those distributive ones. Remember I said I would actually do the problem as it's set up here. I would not distribute that matrix. Reason why? Because then we'd have to multiply things twice. I only like to do multiplying as little as possible because it takes up so much time. So, can we add these two matrices together?
Yeah.
What's our answer going to be? What dimensions? A 2 by 2, right? Times, what are the dimensions over here?
2 by 3.
A 2 by 3. Will we be able to multiply those? Yes. So that's kind of your looking at it, can we actually do this problem? Will we be able to? Yes, we will. Okay. So when we add these two together, we get a 2 by 2. Go ahead and add those up. All right, what's this matrix that we get when we added those two 2 by 2s? What's in this box in the top left? A 2. What's in the box on the top right?
4.
Bottom left? Negative 10. Last one? 12. So far, so good? Are we okay so far? Question so far? All right, now what can we do? You have to do a box because this is multiplication. What's our answer going to be? If we're multiplying a 2 by 2 times a 2 by 3, which we have right here, what's our answer have to be? 2 by 3. Middle numbers, take out middleman, we have a 2 by 3. Here's my big box. Remember, circle rows in the first. Circle columns in the second. That's going to help us organize. So we have 2 rows and we have 3 columns. In the top row, what numbers do we use? What do we use in this top row? 2 and 4. Top row was 2 and 4. So each of those boxes gets a 2 and a 4. Okay, across the bottom row, what numbers do we use? Negative 10 and 12. All right, first row. What numbers do we use in this first row? Negative 2, negative 5. Middle row, what numbers are we using? 1 and 4. Last row, what numbers are we using? 8 and negative 3. Okay, remember you're taking each of those pairs, you're multiplying them, then you're going to add it with the other pair. So from there, you can just put it right in your calculator. What are we going to get from this very first box? 2 times negative 2 plus 4 times negative 5. Negative 24. All right, top middle. 2 times 1 plus 4 times 4. Put in your calculator. What are we getting on that one? 18. 2 times 8 plus 4 times negative 3. 4. Negative 10 times negative 2 plus 12 times negative 5. So 20 minus 60. What do we get that time? Negative 10 times negative 2 plus 12 times negative 5. What was it? Negative 40. Sounds good. Okay, middle one. Negative 10 times 1 plus 12 times 4. What is it? 38. Sounds good. Last one. Negative 10 times 8 plus 12 times negative 3. So negative 80 and negative 36. Negative 116. Okay, and that's your final answer. Alright. So if you look, the front side, like we mentioned, has all the matrices up at the top, and then it tells you what ones you're going to do. On the back, it actually has the matrices written out using the order of operations also. So you guys have the rest of the time to work.